Everybody, my project is dynamic scheduling of dedicated servers for multi-priority level classes of customers with option in cloud computing. And I have done a simulation. In the simulation, there are basically 4 parts. We are shifting the loads of the overloaded server to the next server which is available to accommodate load in a manner that after even accommodation of the load it is not overloaded. This is the basic concept of this simulation. So this is the coding, this all is the coding. So here is the main function. I will run it. Alright, so as I told you, this is the simulation. So we have used the random numbers here. We have taken here 20 servers, and these to show the loads we have used the random numbers. These are maximum value can be 100 and minimum value can be 0 for each server. So in the proposed method I have given 100 servers, but we have done simulation for only 20 servers. So there are 3 concepts. The first concept is simulation of the loads, that is done till here. Okay, the next concept is for every server S1, S2, S3, S4, S5, for every server it will calculate 3 things: threshold, skewness and temperature, and then it will calculate the average skewness of every server, like taking every server into account. After that it will list the servers which are having more skewness than the average skewness. So these are the servers which is having more skewness than the average skewness. These are the servers we can see. After that it will find the hottest temperature in the server. Like here, according to the this skewness they have calculated, S15 is the hottest temperature and the least temperature is S20. So it is clear that S15 is the overloaded server, and from S15 we are shifting the extra load to the server S20. Okay, and this is the migration. S15, these 0 was the more load than the capacity of the server. So from S15 to S20 they have shifted. This is S15, this is S20. All the 0 loads has come to S20. Now we can see here till here. For proof we can go on S15 and S20. We can see the values on S15. This is the S15. The last value is 19. First value is 34. S20, only 3 values are there, last value is 29. So 34 should be listed after 29 because 34 is creating the load. So we will see here, after 34 is listed after 29 and 34 was here, so this load has been shifted to here. Like that, all the zeros that we are seeing, this load has shifted to from S15 to S20. So by here, by this line, the first loop has been completed. Like that, it will again find the average skewness, again temperature, again the hot spot, again the cold spot. This will keep repeating until all the servers will be neutralized and none of them will be overloaded. And the benefit of that is the same load will be there and many of the servers will be completely idle. For example, here S7 is completely idle, S15 is completely idle, S16 is completely idle. So the load remains same, resources remain same, but we have distributed the load in such a manner that few servers are idle and they are ready to accommodate more and more load. So this don't have only advantages over the existing system, but it has some benefits also. Like the service provider can accommodate more loads in the same existing configuration of the servers that he has, and it will keep continuing until the average skewness will be none, NaN. Okay, so to see how much accurate it is, we have plotted the graphs before migration and after migration. To see the before migration values of the server, this is the before migration values. To see after migration, this is the after migration values. Now we will see the graph. Graph panel.java is the graph. It will plot. This is the address from where it is taking the values. So to see how accurate it is, we will see we will compare both of the graphs. This is graph before migration, and this is the graph after migration. Okay, now to compare both of them, I'm going to minimize them. Okay, now see, every time we will run this code, every time different graphs will be generated, because these values are the loads on the server migrated are random values I'm using, because it will need many servers. So hopefully we have a random function, so we have used the random variable. Now we will see, there are different servers. X-axis we have taken servers, and on Y-axis we have taken the loads, which will vary. Highest load will be 100, minimum will be 0. Okay, so here we can see server number 2 is having loads about 20 or something. Here server number 2 is more capable, and it is having load about 31. So like that, it will distribute. Different servers will be having loads different capacity. So according to the capacity of the servers, it will distribute the load. From the some servers may get overloaded in a very small amount of load, and some is capable of taking more loads, so it will distribute the load in a gentle manner, and overall load is minimized, we can see here. So that's all, and this is the file. We have how we have plotted the graph. This is before. There are two files at the same address. This is before and this is after, and this reference is going to before one reference is going to this one, and after that address refer to this one, and this is main function is in this start.java, and we are creating two files in start.java. Somewhere it will be if the here file like this, we are creating the files. Here we can see the file f.create 1.n.s. 1 if the first value is 1, that means before migration. If the first value is 0, that means after migration. And n means the number of servers. Here n is 20, and s means the load on that server. Like that we have done. So as we can see, this 20 number of servers are there, but it is starting from 1, so it is coming till 21, or it will be from 0 to 20. This is after migration. As we can see, the loads has minimized 6, 7 and 3. Total load, if we will see, it will be minimized. So that's all, and thank you.